This is lesson 1 for central angles. First thing, definition of a central angle. A central angle is an angle formed by two radii where the vertex of the angle is the center of the circle. So the example we have here is angle APB. That's our central angle. An arc is a continuous part of the circle between 2 points. So the arc formed by our central angle right here is arc AB. The way I'm going to write that, use capital letters for the two endpoints, and then you put an arc above that. So we would read that arc AB. You may wonder, how do I know I go the long way or the short way? I go clockwise or counterclockwise? There is no rule if you go clockwise or counterclockwise, but if you want to go the long way around the circle, if I want to start at point A, go through C, and stop when you get to B, that's considered a major arc. A major arc is more than half of a circle. A minor arc is less than half of a circle. So if you see two letters, you know that's a minor arc. If it's named with 3 letters, then you know it's a major arc. The measure of an arc and the measure of a central angle are the same. So the example we have down here, we're given a 155-degree arc. We know that that means the central angle is also 155 degrees. So this arc, they're telling us, is 120 degrees. So we know the central angle is 120 degrees. The example we have here, they're asking us for the measure of this arc, and they're giving us the central angle is 123 degrees. Therefore, we know the arc is 123 degrees. If they were asking us for this arc, we know a full circle is 360 degrees. Therefore, half of a circle would be 180 degrees. So if we were looking for this arc or this angle, we would just take 180 and subtract 123 from it. Let's try some more complicated ones. This time they're asking us for the measure of arc CFD. It has 3 letters, so we know it's a major arc. It's going to go a long way. So it tells us to start at point C, go through F, and stop when we get to D. So it looks like we're looking for the full circle minus this little piece here. So if we can find that little piece, we're going to subtract it from 360, and that gives us the measure of our major arc. Again, we know that half of a circle is 180 degrees. So if I take 180 minus 135, it looks like our missing piece here is 45. Again, we know half of a circle is 180. So if I take 180 and I subtract 81, looks like we're at 99. Now I'm going to take 99 and I'm going to subtract 45. Looks like that's going to give us 54. So I now know that this central angle is 54 degrees, and also that means this arc is 54 degrees. So to answer their question again, what's the measure of arc CFD? We're going to take 360, we're going to subtract 54, and it looks like our major arc is going to be 306 degrees. Last one, here we go. This time we want an angle. We're looking for the measure of angle SPQ. So start at S, go to P, and then go to Q. So we're looking for the measure of that angle. So if we can find the measure of the arc it creates, it's called an inscribed arc, then we'll find the measure of that angle. So we're going to start with 360 degrees. We're going to subtract the 154. We're going to subtract the 60. And we're going to subtract the 86 and see what we have left over. So I'm going to grab my calculator. 360 minus the 154 minus the 60 minus the 86. It looks like we have 60 degrees left over. So that means this section here is 60 degrees. They're showing us that is divided evenly, so we know each of those are 30. So let's answer their question again. The question they're asking us, what's the measure of angle SPQ? We're going to add 86 to 60, and it looks like that angle would be 146 degrees. Please try the U-Try problems. If you have any questions, send me an email. Thank you.